Hello and welcome back to Conquering the JavaScript Interview. As we march forward in our JavaScript adventure, today's episode narrows in on not one, but two closely related array methods, find and findIndex, right? They're sometimes often kind of confused or misunderstood, so it's time to put them under the microscope and get ready to pinpoint our way through some arrays. So let's find out, but first I'd like to mention to check for a link in the description down below for our Covalence community membership. For $25 a month, you get access to our front end and our back end courses. When you combine them, make our full stack program. I also have a standalone advanced React course, as well as some other courses I have in the works that you will just get as part of the membership whenever I get them released, as well as any updates to our courses or our content. Not to mention access to our Discord, where you can get some real-time help and support and mentoring from me and other people in our community, as well as customized content, as some of this content I make on YouTube was just generated from a question in our Discord. So if you have interest in that, once again, check the description down below for a link. Otherwise, let's talk about find and findIndex. Both the find and findIndex methods made their appearance with ES6, which is, I think, ECMAScript 2015, I can't remember all these dates, specification. These methods were introduced to enhance developer experience by providing built-in functional ways to retrieve the first element or its indexed based on a test function. That's important to keep in mind. So whether you're searching for the first item in an array that matches a condition or trying to locate its exact position, find and findIndex are your allies. They're often employed in scenarios like data validation, input checks, or quickly locating data points in a set. And I should say not set points, plural, but point, singular, because that's the important thing to remember about them. They both behave fairly simply, where we simply begin iterating over the items in the original array. For each item, we apply some kind of provided callback function. And then if the callback returns true, for find, we return the item itself. For findIndex, we return the index of the item. If no condition satisfies the callback, find returns undefined, where findIndex returns -1. So that's how these things work. Just like the filter array method, which is my first video in this little array architect subseries I'm doing. We also had to remind ourselves the specifications of a lot of these methods, and that not only do they take the element itself of what you're iterating over in the callback, but you also should have access to the index and the array itself should you need to use them inside of your callback code. They need to be provided somehow, and we can actually do that with our code just like we did in that previous video. So, there are pros and cons to all these things, right? Precision, clarity, and immutability are big, awesome pros to using find and findIndex. Performance-wise, anything that uses a callback inside of a loop like this will be less performant than a hyper-optimized for loop. Again, we can mess with that at the end of the video to see if there's any kind of benefit. And the other big con about these is that they are both single results only. So both methods return after the first match. That's the big key takeaway of find and findIndex. So they're not very suitable for scenarios where multiple matches are required. Remember, that is an issue. You might want to look into filter or something like that instead. So I kind of rambled about this in the last video, so I figured I would make it a bit more to the point here in this one. So the solutions I'm going to write here are going to modify the array prototype object. This allows us to add custom methods directly to the array object, which is what we do in this little video series, what you might do in an interview or what you typically see online. This means that every array we create thereafter would automatically inherit those methods. In this example, these methods provide a clear way to demonstrate how native functionalities can be emulated, right? So this is an educational demonstration. Extending the array prototype gives that direct comparison with native methods so we can see how they're potentially written and added. It's an illustrative tool to help understand the inner workings of JavaScript built-in array methods, but they have a lot of cons, and I don't recommend you actually use them outside of these educational learning interview settings or environments. They have unintended side effects, right? Adding array methods to the array prototype object can lead to unpredictable behaviors in code, especially if other libraries or scripts also modify the prototype. It can lead to confusion. Anyone coming in where you don't document the changes you made can have a lot of confusion when they're all of a sudden these random native methods are appearing on array objects they're not used to seeing. as well as enumeration issues, right? So extending these things might cause problems with things like for in loop, where custom methods might get enumerated along with array elements. So this is a powerful technique to know, but honestly, you never really do it. So with that in mind, let's actually jump in on the code here, as I think I'm done rambling about this stuff. So just like the prompt says, we're going to implement our own versions of these and maybe do some code speed tests along with them and check it out. So let's start with the find method. We're going to call our own version custom find. So we're going to take the array object, we're going to modify its prototype by adding our new custom find method on here. It's going to be assigned a value of a function. This is the code that's going to run when we invoke the custom find function. The callback function we're providing is right here written as the callback. Just like in yesterday's video, my cat Percival knows when I'm trying to record content during the day and has this fun habit of coming up here and disrupting me only when I'm recording. He's like right, but there's his tail in the video camera there. He'll come say hello in a minute, possibly. Okay, so this is our callback, what's going to be running our condition, as well as what's going to be passing up out of this code the array element itself, the index of it, as well as the array itself. Remember, in JavaScript, the keyword this derives its context from the thing to the left, which when we call the custom find function on an array, it will be the array itself, represented by the keyword this. So we're going to write a for loop inside of this code here that is going to set up a variable or iterator at 0. We'll continue for as long as the array has elements represented by this.length. Remember, the keyword this represents the array we're iterating over, or whatever .custom find is chained onto. And we'll increment per one index at a time, like we would do with an array. We're going to have a condition right here where we're going to invoke our callback function, and like I had said, we got to pass up each element of our array, the index itself, as well as the array itself as it's needed. This way we match the specifications of findIndex and all these other array methods. They typically have these 3 args in this order. Now, if it happens to find something that matches our condition, we simply need to return the element in the event we get custom find. And because we're trying to emulate the specifications for our find method, I'm going to return undefined in the event it can't find something. And there we go. There is our custom find method. While we're here in coding, let's go ahead and add our next one, our array prototype, custom find index, our own version of it. If I can learn to type, there it is. And just like in the other examples, we'll have a function, we're going to pass a callback, and there we go. It's going to be very similar code here, so I might as well honestly just copy the code, because again, as developers, we'd rather hit the up key 1,000 times in our terminals, our bash shells right here, than write the same command twice. So I think there's like a relevant meme or XKCD about this, I'm sure. Anyway, get in the comments if you have one. If you know the relevant XKCD, or like I think it was like a programming humor meme GIF, whatever, that someone just was hitting the up arrow key a ton until they found a command like npmi or something like that, or cd some folder, and that's all they wanted it to do rather than retype it all. Anyway, back to custom find index. It is going to do the same thing. Loop through each element of the array, apply a callback with a condition inside of it with the 3 parameters of element, index, array itself. But instead of returning the element, it returns the index of said element. And because it's returning an index, aka a number, we also are going to be switching the return undefined to a return -1. In a lot of these specifications, that they return a numbered value, the -1 means it is not there, rather than undefined or null or something like that. But there you go. There are our 2 implementations of our native methods, custom find index, to gain a better understanding of how this stuff works under the hood. So let's go ahead and console log some values here. I'm going to go ahead and grab our input array, which is just 1 through 10, an array of values here, no big deal. I'll go ahead and just do it nice and quick. We'll say input R is this lovely array. I'll say input R find, or rather custom find. I was just use the regular find method. I think it said like, find the first even number. It doesn't matter what they are. Find the first even number. So we're going to say custom find the first even number. For each number we're iterating through, return the first one who is evenly divisible by 2, which I believe should be 2 in this array right here. So there is custom find. Let's go ahead and do custom find index to make sure that they both work at the same time. I'm going to save the file. The first element that satisfies the condition is indeed 2, and its index position for the second console log is 0 and 1. So yeah, obviously it's working as expected right there from the logs above my head. I don't think we really, I mean, first number less than 5, I mean, that'd just be 1. That's a stupid condition. I don't know. I mean, I think I just changed it from yesterday's video that I made where it had less than 5, where it made sense for the filter method. I should have made these better conditions, but who cares? First number greater than 7, that should be 8 with an index of 7. So let's go see if that works here as well. I need the first number that satisfies the condition of greater than 7. So in the event it's custom find, greater than 7, not equal to, would be 8 indeed, and its index position would be 0, 1, 2, 3, 4, 5, 6, and 7. So there we go. My two little methods right here are working no problem. So remember, we initialize both of these by start iterating over items in the original array. We apply the callback, right? For each item, a callback function is invoked. If the callback returns true for custom find, return the element. For custom find index, return the index. And then finally, if no item in our loop satisfies the callback, return undefined for find, return -1 for find index, right? So like I said, you'll see this a lot in data validation, in e-commerce, and gaming, and things like that. You're going to see logic like this all over the place. And find index are a cool duo. And because they're so related, I didn't want to try and juice this content for 2 videos, so I figured I'd include them both here. Yeah, I mean, in terms of optimization, it's the same stuff we saw in the previous video, where writing a for loop would be a better optimized scenario than we would have for our custom methods here that have these callbacks. I mean, I don't know if it'd be as cool or exciting to show as yesterday, but I can go ahead and do something similar where we can have const large array equals an array from a length of 1e6, which will generate 1 million elements in an array. And because we don't care about the elements themselves, I just care about each index of the elements. So we can see this underscore represents each element. This would represent each index of said element. And then this, whatever variable we make, would represent the array itself if that's available. I'm simply returning I plus 1. So this should give me an array of 1 million elements. So for my large array, we can do 2 quick custom functions here. I can write a function, and find index, whatever. We're just going to try and do something interesting here. So we're going to say speed test callback find. Yeah, there we go. Callback find. There we go. It's going to take an array as its input, and all it's going to do is return an array find of the number that's like, I can't say the first even number because that'll find it almost instantaneously. So we can say maybe find like whatever number would be, let's see, where like just find like wherever like the number, I don't know, wherever number is equal to, if we have 1 million, I mean, I guess we could do 500,000, right? There we go. The first number that is 500,000. I'm going to copy and paste this code here for a quick speed test loop find, like that. And what I'm going to do is say for, just like yesterday, we're going to do a I0, len is array.length, so we can optimize it, even though that does happen under the hood already. It's good to write, if you're trying to write hyper-optimized code, even if you know the engine's going to help you by caching like the length property of an array, it's still good to write mindfully written code, right? So we're going to say as long as I is less than len, I plus plus, if num is 500,000, return the number, because, well, that's what find does. It finds the element, whereas find index is the index, and so this will return the number, right? So yeah, I mean, and then again, because if this all goes through, we return undefined, just so we keep practicing the specs of what find does for us. But yeah, there we go. Let's go ahead and nuke those examples down there. Let's go ahead and call my console logs here, where I'm going to say console.time find method. Then we're going to run our speed test callback find with our large array. Console.time end of the find method. I should have just copied and pasted it. So here we go. Then we're going to do one for the other one, which will be the find loop speed test loop find save. Whoopsies, what did I do? Speed test loop find. Did I have a error I didn't notice here? Cannot find module throw error. What have I managed to do, y'all? Large array, no typos. Did I have a typo somewhere that I just didn't notice? That's interesting that it crashed on me. Come on. Num is not defined. Oh. Yep, my bad. Because of the copy pasting and the way I was talking here, get in the comments if you saw me make this error. We all make them, folks. So, whoopsie. Classic conundrum, little mistake right there. I'm so used to working in my fancy little callback functions, being able to call the element of the array whatever I want. I just kind of autopiloted right there. So I'm not going to edit this mistake out. I'm going to leave it in because it's a good way to see an error that we caused and how to fix it. So let's try that again. Save the file, Luke. And yeah, I mean, even over 1 million elements, there's not a lot of time saved here, but nevertheless, there is time saved. Every time I save this, it'll be a little bit different. Yeah, so generally, it's still about half-ish, half the amount of time based on large arrays. So remember, loops are the way to go. And I feel like in this little array architect series here, even though this is total like overkill for this demo to show you this little sample right here, I still think it's cool to know how not only these array methods that we use all the time work under the hood by writing them ourselves, but we also learn something about how to convert them back over to for loops should we ever need to. And that's also a great skill set that I tell a lot of my full stack students in our program, our Catalyst program, they should know and learn how to do because it'll improve their skills as coders. Hey, all these array methods you use, try running them first as a traditional for loop with variables and set up what you need. And then when you understand how to do it that way, then start using some of the nice shorthand and this callback syntax that a lot of these native methods take. I think, again, it's just a cool skill set to help newbies really flex those muscles and practice writing code, understand what they're doing and using even further behind the scenes. So yeah, that about rounds it out for this video. Remember to check the description for a link to both the CodePen that will have this code inside of it, as well as a link to our community membership if you're interested. So thanks for deep diving this content with us today. I'm going to continue unraveling the mysteries of JavaScript native functions. So we hope that expands your tool belt of knowledge. So give us a thumbs up if you found this enlightening. Consider subscribing for more explorations. Get in the comments if you want me to cover a specific array method sooner rather than later, because I'm just kind of making this up as I go. And until next time, keep those codes running and those bugs at bay. Happy coding.